Okay. I will start by going through my test page, and in here we have from here we have all my function declarations. Down here create an unsigned char pointer, one with video output 2, temp output 2. Then I have a texture for my filters, video texture and video texture 2, one for RGB colors and one for grayscale. Then I'm creating two integers, the width and the height of my image. Then I'm creating an integer called next and an integer called brightness C. First off, let's go to my key pressed here, where I use next and brightness C. So if you press N, next will get added 1 to it, and if you press B, next will get withdrawn 1, and the same with brightness C. Now let's see up in my switch case. I have a switch case. I have a switch case here. I have a switch case here which uses next, and as you press N and add values, it will go through the switch case, and if you press B and withdraw, it will go back through. Now let's start with my first function, which is invert pixels. It takes some arguments right here. Then we have a standard for loop. This for loop will run through each pixel of my image and set each pixel the output I to 255 minus the input pixel, and this will give us the negative of each pixels. Now we have simple brightness, where we'll use the brightness C, where you can add and withdraw a value, or 0.1 to brightness C. Again, we have a for loop running through each pixel integer called sum, and I put this integer sum equals to my input plus the brightness C. Then I have if statement here, that if it says if its sum is bigger than 255, just set it to 255, and if it's smaller than 0, just set it to 0. Else set sum to input I, which is the given pixel, plus the brightness, and then my output pixel equals to sum. Now we have my log filter, which is which again we have a for loop running through each here, and then I'm creating a double called temp, and and that double temp, I set it to 255 divided by log to 1 plus 255. Then I'm taking my output pixel and set it to my temp times log 1 plus input I, and this will give me the log filter. Then we have the exponential filter, which works pretty much the same way. For loop running through each pixel, then creating my double temp, which I set to 255 divided by, and instead of log I do it with power 2, and then I set my output pixel I equal to the temp times to the power of input pixel I minus 1, and this will give me the exponential filter. Then we have my salt and pepper nice, and here instead of using one for loop, I'm using 3 for loops, one for the height, one for the width of the image, and one for each color. Then I'm setting my output equals to my input, so that not all the whole image will become salt and pepper nice. And then I'm creating an integer called num with random modulus 100, which will give me a random number, and if this number is smaller than 12, I create a new integer called num2, and inside that I put rand modulus 2, and if num2 is 0, then I will set my output and the given pixel value and position to 255, else I will set my output given pixel position to 0, and this will generate RGB salt and pepper noise. Then we have RGB to grayscale, and this is pretty simple. I have 2 for loops running through my image, and for each pixel I will get the red value, the green value, and the blue value, RGB. Then I'm creating an unsigned char sample where I multiply all the colors and divide by 3, and then I'm setting my output pixel position to be equal to sample, and this R plus B plus G divided by 3 will give the grayscale value, and then it will give a grayscale image. Then we have grayscale to binary. Here again I create the grayscale the same way up here, and the only difference is my if statement, that if sample is smaller than 228, set it to black, else set it to white. So this divides my grayscale image into 2, black and white, and turn it into a binary image. Now we have RGB to normalized RGB, and again I have 2 for loops running through, giving me red, green and blue value, and for normalized RGB we need the sum of red, green and blue, so therefore I create a float called sum, and inside sum I'm putting red plus green plus blue plus green value. Then I have a for loop for C for my switch case and my colors, and in this I'm setting the output equal to unsigned char with the red divided by the sum times 255, and I do that for each color, and this will give me normalized RGB. And again, this is the position of the pixel. This is the 3 colors. This is what color it is. And green divided by sum times 255. Now we have the acres filter. I should mention at the beginning, when you take acres to something, you can't do it with a very high number. So we have a for loop which will run through each pixel. Then I create a double temp 1, and I will put my input in that. Then I create a double temp 2, where I will take temp 1 and divide it by 100, because you can't take acres to a high number. Then I take acres to temp 2, and then last I take temp 3 and times it multiplied with 100 to remove this divided by 100. And then I set my output given pixel to be equal to temp 4. This will give me the ACOS filter. Then I have my Serbia filter. Again, 2 for loops to run through, giving me red, the green and blue value. Then creating grayscale mod of it, again, to keep me in range, I said if sum is greater than 200, just set it to 200, and if it's smaller than 0, just set it to 0. And then I'm taking my output pixel value for red. These indicates what color it is: 0 red, 1 green, 2 blue, RGB. And I set it equal to sum times 112, because in a Serbian filter you want this brownish look, and therefore you need red, very little blue, and some more green, and this will give me a Serbian look filter. Then we have a pink color detection, again running through the image with 2 for loops, giving me the red, the green, the blue value. And then my if statement here checks if blue is greater than green plus 30 and red is greater than green plus 30. This will give me a pinkish value. Then set it to 255, else set it to 0. So pink in this case will be white, rest will be black, or the pinkish color. Then we have my dilation. I have my kernel here, 1111. I'm running through the pixels here of the image. I'm creating an integer called sum, put in 0. Then I'm running through my kernel. You can see here -1 to 1. This is -1, 0, 1, -1, 0, 1, and so on. That's how it works. So this is -1, this is 0, and this is 1. As you can see, -1 to 1. And then I check if my input pixel with the kernel is 255 and my dilation filter is 1. If this is true, then I take my input and I add my then I take the input and the position of the kernel, times it with the width, and divide it by 255. And then if sum is bigger than or equal to 1, set it to 255, the output value in position, else set it to 0. And erosion works the same way, except that if sum equals 9, I should set it to 255, else you should set it to 0. Now we have my test app here, which I will go through. The width of the height of the image. Next is for my switch case, so you can go back and forth through the filters. Brightness to turn up and down the brightness. Then I have video output 1 and 2. 1 for RGB, that's why I times it with 3 here, and 1 for black and white, that's why I don't need it. Then I also have 2 temp output and temp output 2. The reason I have these is because when I have to do an opening and closing, I have to save some temporary values, and I will do that in here. And then my switch case is here. Now let's see the program run. Is there something I'm missing? No, we have the draw function where I draw texture and texture 2 for grayscale and binary, texture 1 for RGB image, and here's the original image. Now let's see how it runs. Oh, This is the 2 seconds. I'll just here. This is the inverter, as you can see. Very good. This is the simple brightness. Let me just turn it up and down. Darker, 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 darker. There we go. The next one, this is the log filter. Then we have the exponential filter. This is a bit darker. And then we have salt and pepper noise, and as you can see, it's red, green, blue salt and pepper because it's in an RGB photo or video. Then we have my grayscale. See, it switches over here. Yes, looks good. Then we have my binary. Also works good. Then we have my normalized RGB here, switched back, and the way I can do this, you can see my switch keys in the background, where I switch from video output to video output 2, grayscale, then I go to video output 2, and then in normalized RGB I go back to video output. Yes. Then we have my next one, which is the acres. Remind me of negative. Really cool filter though. Then we have the savior here. Yes. And here we have, oh yeah, that's pink detection. Let me see if I got some pink here. Got some of my girlfriend's name. Oh, that wasn't pink. Let's see what we got here. Got some pink here. As you can see, pink detection Act 15 it says. There we go. Pink detection. Everything else is just black, but the Act 15 is white. The next we have my dilation. As you can see here. Very good. Then we have my erosion. Right here. Works pretty good. And then I created an opening by first running my binary function and then using the temp output. Then I'm running the dilation using the temp output. And then I'm running the erosion using my temp output. And here I do the same. Let me see. You can see the difference between dilation and erosion. Yes, that was it for me. Thank you very much.